So, good morning, crewmates. Okay, so welcome to the 12th HugNayan Space Science Forum. By the way, um, okay. So again, good morning to each and everyone. So welcome to the 12th HugNayan Space Science Forum. By the way, I'm Engineer Sandy Kak Jr. I'm a science research specialist under the Interdisciplinary Space Missions Development Division of the Philippine Space Agency. And I will be the master of ceremony for today's event. So a warm welcome to our on-site participants here at PhilSA conference room, and also to our online participants joining us via Microsoft Teams and also via YouTube Live. To give you a bit of background, the HugNayan Space Science Fora is organized by the Interdisciplinary Space Missions Development Division, or ISMDD, under the Space Science Missions Bureau. The goal of this event is to deepen the understanding and appreciation of space science among both PhilSA personnel and our external participants. And so we hope that this event will lead to new opportunities for collaboration and advancement in space science research and development. To start off today's event, let's welcome Dr. Joel S. Marciano Jr., the Director General of the Philippine Space Agency, to give the opening remarks. Let's all give him a warm round of applause.
Salamat, Sunny. Good morning, everybody. Good morning to colleagues from PhilSA, to our distinguished resource person this morning. Welcome, everyone here on site and all of those viewing. So this is, again, our HugNayan. It's time for this very meaningful activity. And Monday morning notwithstanding, we're always, syempre, eager to learn about new things, expand our horizons. And I should say, yeah, Monday morning perhaps is the perfect time to do such a thing because we have the entire week ahead of us and many chances to apply what we learn on a Monday to the rest of the week, and not just that, but moving forward. No? So this is, we're discussing today applications of nuclear technology in the realm of space, particularly space exploration. Right, and that's a very critical factor. It's when we build satellites and when they go into orbit, they are of course affected by the conditions in space. Among others, there's cosmic radiation, and these are satellites, no? But there are also astronauts certainly that go to space, and it's very important to understand and not overlook the impact of the environment, the space environment, such as radiation, on their health. And they're exposed to various risks. And this, therefore, whether it's for infrastructure or for astronauts, it highlights this need for more research, more collaboration, particularly in areas like radiation shielding technologies and other implements that will protect both equipment and the individuals who venture into space. And so the message, I guess, today, as we learn from our distinguished resource person in this HugNayan, is once again collaboration. So as a space agency, we touch many fields, and likewise, we in the spirit of everyone here and the people we work with becoming more T-shaped, we must, in order to address larger societal scale or global challenges, we have to become T-shaped. And that means having the skills, not just the technical skills that are vertical, but the horizontal breadth of skills that will allow us to find areas of synergy with other groups and come up with more meaningful outputs by working with them. And so on that note, I encourage everyone to engage, be asking questions, all of those online as well. Thank you for joining us. And it's indeed a pleasure to welcome our esteemed speaker who will be introduced, I think, afterwards. And she will provide insights into her significant contributions in nuclear research and development here in our country. And let's also endeavor to learn more about our country's nuclear energy program, because PNRI has a very vital role that they're playing in this important initiative that also, of course, addresses energy requirements, but also ensures the health and safety of people and everyone involved. There, as we know, there's many applications of um, nuclear research. It's not just in energy, as we know, it's also in food security and many others. And so on that note, let's work together, leverage our collective knowledge and understanding and resources, and let's ensure that the Philippines plays a significant role in the future of space exploration through synergistic collaborations locally as we build our ecosystem, our Yamang Kalawakan. Let us contribute to strengthening that further today with this HugNayan. And thank you very much, and I look forward to our discussions. Good morning and mabuhay. Thank you.
To do the honor of introducing our esteemed resource speaker, may we call on Mr. Win Dunhill Improso, Senior Science Research Specialist and the Officer in Charge of ISMDD.
Thank you, Sunny. So, welcome to our HugNayan this morning. Our speaker, Dr. Vallerie Samson, is currently serving as the Deputy Director for the Philippine Nuclear Research Institute since 2021. She finished her bachelor's and master's degree in physics at UP Diliman and obtained her PhD in materials and science engineering from the University of Tsukuba in Japan in 2012. She had her postdoctoral research at the National Institute of Material Science in Tsukuba, Japan after finishing her PhD until 2014, and then later joined the Micro XAS project of the Paul Scherrer Institute in Switzerland as a Marie Curie postdoctoral fellow until 2017. Then she became a visiting scientist for PNRI and taught as an assistant professor at UP Diliman. She then became a DOST associate scientist and was later conferred the rank of Scientist 1 under the Scientific Career System in 2021. So as the Deputy Director, her responsibilities include provision of executive direction of all functions of the Institute, formulation and adoption of a comprehensive nuclear science and technology plan, including manpower training, infrastructure, and institution building and monitoring, supervision and control over all units in the implementation of their work plans, assisting in the establishment of policies and guidelines for nuclear research and development, assisting in directing the implementation of nuclear regulations and licensing responsibilities of the Institute, and approval of the rules and regulations necessary to carry out all functions and objectives of the PNRI. She also was, I also met her in our collaborations and research in physics. And without further ado, please help me with Vallerie Ann Samson.
Magandang umaga po sa inyong lahat. Pleasant morning to each and everyone. It's finally, I have the pleasure of being here. This is a long time coming. We've been planning this since early part. There's the first quarter of this year, and a little bump, some bumps along the way, especially with my schedule. So I'm very, very apologetic to PhilSA for the long wait, but finally I'm very, very pleased and happy to be here with you all this morning. The title of my talk actually was, we've been thinking long, what would be our title to recognize our role as nuclear, and then also PhilSA being the space agency. So for this morning, I'm proud to present my presentation of PNRI landing on PhilSA, bringing a galaxy of nuclear applications, and of course, with my talk on bringing all these nuclear applications that we have in PNRI, you will be able to think about all the many areas that the nuclear field and the space field can come together and collaborate. Essentially, our basic science is the same. Essentially, it's radiation science, right? Physics and radiation science, and the things that we do will be more alike in many ways, and so that's why I have collated my talk in such a way that you will be popping out new ideas now. Oh, we can also work on that particular theme. No? So I'll start my talk with what is nuclear energy. Of course, nuclear energy is harnessing the energy inside the nucleus or core of the atom. And there are different processes wherein we can harness that energy. You have the fission and fusion process, mainly used for power or research reactor purposes, but you also have the radioactive decay of several radioisotopes that can be used for irradiation or for medicine or for industry and many other technological applications. So this is how we harness the energy of the nucleus for nuclear technology applications. So what is nuclear technology? So essentially, nuclear technology involves the reaction of the atomic nucleus and with the reaction. So for example, for fission and fusion processes, it emits radiation, ionizing radiation, and other daughter isotopes. But for nuclear technology applications, we are mainly interested with the energy that is being released. And with technology applications, we are also interested in the radioactive decay of isotopes. And in this radioactive decay, there's also a release of gamma energies or X-ray energies that can be used for many other fields. And for example, in the case of X-rays, is a kind of ionizing radiation, but they're actually being produced electrically, no? All right, so this is the emission of different particles or energies using nuclear processes, and this is the emission of X-rays using electrical processes. So you just have high voltage potential between the cathode and the anode, and then with the emission of the high energy electrons from your cathode, they hit the target and then they produce X-rays. So the applications of nuclear science and technology is a bit known for power, right? So if you say nuclear technology or nuclear energy, everyone thinks that it's only power application that we have in mind. But there are also a lot of industries and even in agriculture that use nuclear technology. So if we have several licensees in PNRI, like for example, Coca-Cola uses radioactive isotope as a leveling gauge so that all the Coke in the market will have the same level. So it's called a leveling gauge, and they use radioactive source to level that. Don't worry, the radioactive source is not put inside your Coke bottle, but it's outside, and just you have a detector and the radioactive source to check that the level is the same. And of course, even in construction companies, they use radioactive sources. And of course, one of the other known uses of nuclear technologies in medicine. We have a growing number of hospitals offering nuclear medicine already in the country, and also there's a growing number of companies producing radiopharmaceuticals also in the country. And aside from the bigger technology applications, we actually use nuclear technology for environmental monitoring and also in agriculture and in the food industry. So here is the vast number of industry applications that we have in the Philippines right now. So essentially, we have around 10,000 X-ray machines all over the country, and we have 70 nuclear medicine hospitals right now, plus 64 interventional radiology and 75 radiotherapy machines all over the country. We also have accelerators already. 56 are medical LINACs or linear accelerators, plus 4 medical cyclotrons, and we have 2 industrial electron beam accelerators already. One is in PNRI and one is a commercial company in Tanay, Rizal. And you have industrial applications, so people don't normally know that there's a lot of use in radioactive isotopes in industry, but yeah, even in mining companies use radioactive isotopes for their applications, plus of course a lot of industrial X-rays for imaging purposes. In PNRI, we are the only agency in the Philippines that does research in the field of nuclear science and technology. We are the only facility right now that handles radioactive waste in the country, as well as we are the only institute that has the reactor. So to introduce you all to the Philippine Nuclear Research Institute, this is our very beautiful campus at the heart of Quezon City. So yeah, the other side of the road from UP Diliman. So this is Commonwealth, UP is on the other side, we are on the other side. I'll tell you a short story later why it was built like that in the 60s. So we have been in Commonwealth Avenue since the 60s. So we are one of the very first buildings around the area. So we are located in the Arboretum in the deep forest of Diliman, Quezon City, and this is our flagship building. So it's we call it the itlog, no? Yung itlog sa Commonwealth. But now young kids don't recognize it was a main landmark in Commonwealth during the 80s, 90s, and even in the 2000s. But now because of the UP Techno Hub, the kids don't see the itlog anymore. No, only the oldies, only the oldies recognize that there's an itlog somehow there. So the PNRI in 1987. So we were born in the 60s, but we have been reorganized during the time of President Corazon Aquino to be integrated with the Department of Science and Technology. So that's why it was EO 1987, which gives us our current mandate of promoting the peaceful uses. So this is very important. We are only promoting the peaceful uses of nuclear in the country, its research and development, and then undertake also the transfer of research to our stakeholders. And then we operate and maintain several nuclear and research facilities inside the campus. And our dual mandate, we say, is we also regulate. We use and then we also regulate the peaceful uses of nuclear in the country. So later there will be a little bit of story on the licensing and regulation. So if ever in the future that the regulation is still with PNRI, you will have to apply for a license if you want to use radioactive sources for your research. Next slide, please. So this is our mission. And also since we were first in the area, so we actually rent from UP the land. It's 10 hectares. That's why we have a beautiful campus like this. And this is our mission and vision in our strategic plan until 2028. Next slide, please. So I just want to introduce the organizational structure that we have so that you can also compare how is PNRI and compare it with the organizational structure that you have. So we are an attached agency under the DOST. So, but we have our own budget. We don't ask from the mothership already. So we have a director, deputy director, and then we have 5 divisions. 2 of the divisions, the finance and technology diffusion division, is like a support division, while our main roles as an agency and mandate is given by the 3 big divisions: the atomic research division, nuclear services, and nuclear regulatory division. Under the atomic research division, we have 6 sections or units. We deal with agriculture, biomed, health physics, applied physics, chemistry, and nuclear materials research. So that's the research part of for us. And then we have services. So these divisions are income earning for PNRI. Since we are income earning, we do give back to the DBM all our earnings, and it's approximately 40 million pesos per year due to all these services. So we have the reactor operations. The reactor operations right now is still more on the R&D, as I will discuss later. But in the future, if it becomes bigger, then it should be a service division already. Gaining income. We have engineering services, irradiation services, which is one of our very big income earning units. We have a lot of customers from agriculture, food, cosmetics industry, and so on and so forth. Then we have the nuclear analytical techniques application. So if you want your samples to be analyzed, later I will show you also your water samples, your condiments, you want them to be analyzed for stable isotope techniques, then it's the nuclear analytical techniques, plus the isotope techniques also, and the radiation protection services, which reads all the radiation monitoring device of all radiation workers in the Philippines. So approximately 10,000 radiation workers in the Philippines come to PNRI for the radiation protection monitoring readout. So that's why we have a lot of income. And I think among all the RDIs, Research and Development Institutes of the DOST, we are #1 in the income, our income. Then of course, our regulatory, they also earn because of licenses. So if you want to apply for a license, of course, you need to pay. And they also earn for giving out licenses to all the licensees, plus the inspection and enforcement. So we also need to inspect all the, for example, all the radiotherapy machines in the whole country, and as well as the nuclear medicine facilities in the country. We do inspect that. Then we also have a mandate to protect all the nuclear materials in the country. So that's nuclear safeguards and security. Nuclear materials meaning uranium, thorium, and plutonium. So they need to be regulated very much, and you need to be licensed to be able to have that. So that's the PNRI. We approximately we are 230 employees only, but that's permanent. But we have, I think, maybe I put it in the next slide. So next, no. And approximately 150 COS at the moment, because we have, as you see, the breadth of applications that nuclear is already having. Our current number of plantilla personnel cannot keep up already with the number of research projects that we have. That's why we almost 50% permanent and 50% COS positions in PNRI. But we also have a very young, so like you, I like that. I know that PhilSA has a very young population right now. PNRI is also our average age also is around the 20s already, because of the so many COS, very young COS personnel. That's why we are also very, very young. Quite young. Okay, so as next slide, please. As I was saying, although the name PNRI was just in the 1980s, we are actually a very old institute. We are one of the very first institutes under the DOST right now that was formulated in the 1960s. So we were born in the 1960s, but we were not born as PNRI yet. So during the 1960s, where there was a huge interest in developing nuclear energy for peaceful applications, the Philippines, being a friend of the U.S., signed an agreement with the U.S. in 1955, and this was the RPUSA agreement for the peaceful uses of atomic energy in July 1955. And with this agreement, they gave the Philippines a research reactor. So there was a signing bonus, no? There was a signing bonus, and the signing bonus was the gift of the research reactor for the Philippines to develop its peaceful applications of nuclear in the country. And the name of PNRI was actually Philippine Atomic Energy Commission. So it was a commission, it was under the Office of the President. So, like the PhilSA, no? So like the Philippine Space Agency, before we were not under the DOST. And after that, a fun fact also, during the time wherein the International Atomic Energy Agency was being formed, during the 1950s, 1960s, the Philippines being also the first to have such a facility gifted, we were also one of the very first members of the International Atomic Energy Agency. So this is the Philippine Research Reactor, PRR-1, it's named. So this is a very old picture of, if you see there, it's all forest, no one is living around the area, and that's why they built the research reactor there in Diliman, QC, because at that time no one was living in that area, and then University of the Philippines was in front, so therefore it would be a good collaboration between the university and the reactor. So I think they were envisioning that the main users of the research reactor will be the university, no? So you have the UP and then the research reactor in front. So it was a very good scientific layout planning of Diliman, Quezon City. But right now it's a lot of people already. So in the current standards of building a reactor, this is the current site is not anymore approved because you have a huge population around, but we can't do anything. We were first in that area. So this, the very first one was a 1 megawatt research reactor. And then, yes. And then this was the picture when the first criticality of the research reactor came into spark. So the first light, we would say, it was in August 23, 1963 at 2:12 in the morning. So for research reactors, they usually run 24/7, so you don't turn it off. And so that's why the first criticality was a very early morning. 3 of the guys here became commissioners of the then PAEC, but forgot my first commissioner. He became the very first commissioner of PAEC, and then the 2 other Filipino guys also became the commissioners of PAEC. So it was 1 megawatt research reactor. So what is a research reactor? A research reactor is used for research. It is non-power. It does not produce power. All right. In a nuclear power plant, you are harvesting the heat from the gamma. So you are using the gamma to boil the water in the reactor pool. But in a research reactor, you are harvesting the neutrons. So you're not interested with the gammas that are being produced. You're more interested with the neutrons. And by harvesting the neutrons, you can use the neutrons for creation of short-lived radioisotopes or radiopharma production, also for neutron scattering, neutron research experiments, and also for reactor training. So essentially, since almost you are already dealing with a reactor, it will be a kind of training also if you will go into a nuclear power plant. So, but apart from the research reactor, so a research reactor is only one unit of PNRI, but PNRI also deals with a lot of other topics aside from research reactor topics, and that includes biomed, health, agriculture, environmental monitoring, and especially material modification or food irradiation. Next slide, please. So I'll go through some of the nuclear S&T innovations that we have in our recent R&D, so that some ideas will spark into your mind on how we can collaborate. So for the right now, I will just focus on the food and agriculture aspect of the multi-purpose gamma irradiation and electron beam facility, but we don't only cater to the food and agriculture market. So as I was telling Mark, we have Analog Technologies already has sent their electronics for us for irradiation. But essentially, our number one income generating is when the food and agriculture market sends their product to the gamma irradiation beam for sterilization or irradiation. So not only food can be sterilized, bone grafts are also sterilized, orthopedic implants. So the PGH is also a customer of PNRI. So every Tuesday, they send their bone grafts to us for irradiation. And then, of course, spices. So if you have the pleasure to go to PNRI, it's if you visit this facility, depending on the day, it can smell like black pepper. Sometimes it can smell like onions. So depending on who is using the facility, then you'll know, they're irradiating, or green tea. They're also irradiating tea. So you'll know, it smells like tea. So the number one customer of the day is tea. And then even cosmetics, the cosmetics that we use are being irradiated, of course, all to reduce the microbial workload, microbial load of these products. For this, you have the gamma irradiation, which is a cobalt 60, a cobalt 57 source, but we also have an electron beam. So the electron beam is a 2.5 mega electron volt electron beam facility. So you can choose if you want to use the electron beam or you want to use gamma rays. But of course, you need to study first which will be more appropriate for the research that you want to do, because the penetration beam of electrons are different from the penetration beam of your gamma ray. So depending on what you want for your study. And of course, as mentioned, we have a lot of food products or agricultural products coming into us, and that is to prolong the shelf life. Companies do this because by prolonging the shelf life, then your product will be longer in the market, therefore you earn more. So for example, for bananas, instead of just 5 days in the shelf, then it becomes 7 days. And so you have extra 2 days to sell your bananas before they get rotten. And the principle is just because by gamma irradiation, you reduce the microbial load of whatever is on top of your onions, of your strawberries. But of course, before the dose that is administered to these products are sent into commercial processes, we do a lot of R&D first. No, you can't just irradiate bananas at a certain dose and not care at all what will happen to the product. So there's still a lot of R&D before it becomes commercial. So there is a certain dose that the taste, the color, and the nutrients of your agricultural products will not change with irradiation. No? So that's very important, because if you irradiate but the taste of mangoes will be different, then your consumers will not buy your mangoes anymore. One of the very successful irradiation activity that we have, R&D activity that we have, is in the irradiation of a very special carrageenan polymer. And with the irradiation of carrageenan polymer using electron beam, it was able to be made as a organic fertilizer. No, parang with irradiation, the morphological structure of the carrageenan changes, and because of this change in the polymer, and then if you spray your this carrageenan growth promoter onto the leaves of rice, mungo, and other agricultural crops, then the yield of these agricultural plants can be as high as 30% more. So it's an organic, so it doesn't use carrageenan is coming from seaweed, so it's very organic, but it can be used as a organic fertilizer. And you can buy this material already in Shopee. So if you are, and you can use it not even for, not only for rice or agricultural crops, but even if you're a plantito or plantita, they said that if you spray it on the leaves of your plants, the leaves of the plants will be like, they'll be bigger and greener. So even for plantitos and plantitas, this plant growth promoter works very well. So this has been tested, as mentioned, in many crops all over the Philippines. And yeah, right now the DOST is promoting it all over the regions. Next slide, please. And then another application that we have is the irradiation of insects to control insect population. So this is called the sterile insect technique, and the male insect is being irradiated with gamma rays, and because of this gamma irradiation, the male insect becomes sterile, and therefore they will not, if they mate with female insects, then the population, they will not be fertilized anymore, and the population of that certain insect goes down. Currently, our project is with dengue, because dengue is really a very bad problem here in the tropics. We are, it's still in R&D phase, but we're testing it in 2 sites here in Metro Manila. But the plan is in the future, like in other countries like Brazil and in Italy and Spain, they release millions of male insects. So to really curb the population of the mosquito population. But right now we can't do such a mass production yet, so we're still in the low end. Perhaps we're still producing only 500 male mosquitoes per week, but we're not yet Brazil level producing 1 million. But hopefully in the future this will be a major project in collaboration with DOH to curb the insect population. So this right now it was with dengue, but in the past, sometime like in the 2000s, early 2000s, we were very successful in performing the sterile insect technique to the mango pulp weevil. So the mango pulp weevil is a pest in Guimaras, which makes the mangoes have their black dots. They dig into the mangoes and make the mangoes be not good for export. So the Guimaras mangoes are for export. We know that they're the best mangoes in the world. But if you want to export them to countries, then you need to have a very smooth mango, and the mango pulp weevil was one of the culprit, while you have a lot of wastage of these mangoes. And PNRI actually has the standard already. So the world standard on how much radiation dose you will do to your mango pulp weevil for it to be sterile. So PNRI holds the standard for the radiation dose for the mango pulp weevil. Of course, we have mutation breeding. So as you know, if with irradiation, you can also mutate plant species only, no? So we only mutate plant species, and the goal of mutation breeding is, of course, to hasten mutation. You know, mutation in the normal natural scale takes hundreds of years, right? Hundreds or thousands of years. But with irradiation, you can hasten whatever characteristics that you want from your plant. So we have irradiated a lot of plant species already over the years, but currently we are irradiating adlai and sugarcane. Adlai is, if you know adlai, it's one of the, what you call that, for if you're on a diet, no? If you're on a diet, adlai is a very tall plant, so it's like kogon, if you know kogon grass. So it grows very, very tall. Therefore, it's not good for commercial farming, because if you are commercially farming such tall grasses, then it will not be good for the farmer. The farmer will have some difficulty, and therefore we want the adlai plant to be smaller, right? And then because of irradiation, we were able to get that characteristic of the adlai, wherein the adlai after irradiation is stunted already, and this becomes better for commercial farming purposes, no? And also during typhoons, if you have a typhoon, since your adlai is already stunted, then it will not be easily thrown away by the strong wind. So we have done that also. So aside from the very agricultural side, we also, as mentioned, we have the we use nuclear nuclear technology like stable isotope techniques to determine the authenticity of certain products in the market. In the past, we've done authenticity for vinegar. We have tested 300 vinegar samples, and it was made known that some of the vinegar in the market was adulterated. And right now we will also be testing a lot honey. Honey also is one of the current research that we have, wherein we learned that most of the honey that being sold in the Philippine market is sugar, high dose of commercial sugar, and therefore it's not good really if you are trying to use honey for your coffee, no? Instead of, because you thought it was healthier and healthier option, but apparently like 80% of the honey is from commercial sugar. And then most of the honey, though, that is coming from abroad is better honey. So I would advise that if you want to use honey in your tea, go for the imported brand for the moment until we have set standards. So the PNRI is working with the Bureau of Food Standard to authenticate that, okay, for honey in the market, it should be this authenticity that we have. So this is one of the very applications that we have that is straightforward to the market and to the consumers. And we have several filters that are used for toxic pollutants. So this is being used now in the mines and some mine remediation. How you can know if your mine has still copper, iron, chromium, or nickel. So this was also developed in PNRI via irradiation of your grafted abaca. Next slide, please. So then for research reactor technology for PRR1 SATR. So this is the PNRI, the PRR1. However, in the 1980s, when we tried to upgrade the PRR1 from 1 megawatt to 3 megawatt, something went wrong. Something went wrong, and they did not know what went wrong. So in the past, NDT, if you know, non-destructive testing techniques were not yet very popular. So they cannot really assess what went wrong with the reactor. And after they were trying to put the power until 3 megawatt, but only after a few hours it went kaput, or it just went down. And for almost 30 years, we did not know what happened to the reactor. They don't know what really happened. And so for almost 30 years, since the 80s, it was just sitting there without any use. And it was even planned for decommissioned already. So for decommissioning, meaning you will shut down permanently the reactor, remove all the nuclear fuel. So that's it. Remove all the nuclear fuel and send it back to the producer of the nuclear fuel. However, in 2014, the scientists in PNRI thought that why should we shut it down? Why should we not make use of the nuclear fuel? Because there are still approximately 144 or more nuclear fuel in the facility right now. So why can't we use the nuclear fuel for a new type of reactor? So from that point on, we built the SATR. So it's SATR, it's a subcritical assembly. What we mean by subcritical is it cannot sustain nuclear fission, no, without an external neutron source. So normally in a critical reactor, you have an initiator, which is you need to put an initiator first, a neutron source. But once you remove the neutron source, the fission process can go on already. But in this case, if you pull out the neutron source, then it will not sustain the fission process anymore. That's why it's called subcritical. So hindi niya pa kaya mag-isa talaga, di ba? So it's very safe. It's inherently safe because they call it a zero power reactor. So if you've seen the research reactor, it's 1 megawatt, 3 megawatt. This is essentially zero power. It's not zero power. The term is just if it's less than 1 kilowatt, then they term it as zero power. So that's just the term they use in research reactor. So we have developed a new reactor pool, and this new reactor is developed by Filipino scientists, and this reactor assembly is developed by also a Filipino company. So all of the parts were developed by Filipinos, and that's why it's very this is a milestone for the PNRI, because we have shown the world essentially that the Filipinos can, right? That if we are given enough resources, we can do better also. And right now, there's a lot of collaboration on research on subcritical reactor. Even Canada, we just signed an MOU with Canada because they also want to collaborate with the subcritical reactor assembly. So they have a subcritical, we also have a subcritical assembly. So this facility was licensed to operate in 2023. So even after building, we still need to do all the licensing process. That's why it's not so easy also. It's also licensed like a real reactor. You don't license it like a subcritical. So all the safety requirements of a real reactor is the same for this subcritical reactor assembly. So the licensing essentially took like 2 years because all the components, all the safety parameters need to be studied. And since it's a subcritical reactor assembly, it cannot sustain yet very big neutron experiments. The neutron experiments that we have are essentially only for the few neutron dynamics in subcritical. But the main aim of the SATR is to bring back reactor physics and engineering in the country. So as I've said, during the 1980s, there was the BNPP being mothballed, and then unfortunately even the research reactor in PNRI was shut down, and reactor physics and engineering in the country was just gone, right? And most of the nuclear engineers that we have, of course, left for greener pastures where they can use their expertise. But the main aim of PRR1 SATR is to bring back that nuclear knowledge in engineering and reactor physics back in the country. So we do conduct a lot of public awareness. You can all travel to PRR1 SATR to see how the reactor is. The old reactor, you can still see the old reactor plus the new smaller SATR assembly. And then a lot of nuclear education for physics and chemical engineering. So we have some courses in several universities to aid in nuclear education, and then capacity building. So this is the #1 aim of the facility right now, to bring that reactor engineering and operations capability of PNRI, and hopefully we can also translate it to other stakeholders. And in the future, this is still in the future. We have done some reactor model validation, but some of them are not yet operational at the moment. So we're still trying to upgrade this facility at the moment. So at the moment, we're using a a radioactive source for as a neutron starter. We have a project right now led by Dr. Alvi Astronomo to have a electrically generated pump source neutron generator. So it's the neutrons are coming from an electrical source already to increase the number of neutrons that can be generated. Next slide, please. But these are all the research reactor applications if we have a very big research reactor. So this was all the research reactor applications in the past. During the 1960s, actually, we have a very active neutron beam research. So there were like 3 beam lines doing neutron research in PNRI. You have neutron activation and then irradiation. You can also irradiate materials with neutrons. One of the, like in ANSTO, you have a very big research reactor. They irradiate silicon. They irradiate silicon, they call it silicon indentation. And then, of course, for the production of RI and the training facility for nuclear power plant. Next slide, please. So are we happy? So is PNRI happy already with the subcritical? Of course, we are not. Of course, we are not yet happy. We are happy with the accomplishment that we have, but of course, look at all the myriad of applications if you have a full research reactor. So in the future, after we have justified the PRR1 SATR, PRR1 SATR is actually funded by the Philippine government. So the DBM is very, very happy when it saw the PRR1 SATR, because they've really seen how if you fund science, then you see also the fruit of that of what they have invested in. So they're very, very happy with that. And hopefully in the future, we already have a feasibility project on a 10 megawatt. So 1 to 3 megawatt right now in the world is small. So a 3 megawatt reactor is small in the world right now. We want to develop a 10 megawatt, So hopefully in my government service lifetime, I will be able to see that 10 megawatt research reactor. But for now, we are of course very, very happy with PRR1 SATR and hoping that after we have justified its use, we can already propose a bigger one for the Filipino research and development. For the environment, so a lot of people are wondering that, oh, you use nuclear technology for what do you use it for? Don't you pollute the environment? We use nuclear technology for environment. This is a project that just got finished, wherein we were monitoring iodine 131 in coral reefs. So coral reefs are actually very good time, what do you call that? Time-lapse capsules. They see what they record what happens in the ocean at particular time scales. And with our research work, drilling coral cores, we have seen that there is an abundance of a certain kind of radioisotope on one side of the Philippines versus on one side of the Philippines. All right, so this project is finished, but I think they have already published this work on iodine 131 in the West Philippine Sea coral reefs. Then next slide. Aside from that, from the many research that we do, we also monitor the radiation that is coming into the Philippines 24/7, so you can all sleep at night in peace. All right, that the Philippines is being monitored for any nuclear radiation that can come from, let's say, nuclear testing or other uses of the nuclear technology in other countries. This is the comprehensive the Comprehensive Nuclear Test Ban Treaty Organization Station in Tanay, Rizal. It's a very big detector which collects all the air, and then the air is collected, and then it's measured using gamma spectroscopy, and then the data is sent to Vienna on a 20, I think every hour, or it's being monitored by Vienna. And if it's turned off, Vienna will call our station manager, why is your station turned off? Right now with the brownouts that we have, it's a pain to monitor the station, because it's also sometimes it will turn off for several minutes, and then Vienna will call that, why is your station turned off? It's because there's no electricity. But we have generators. We have generators on standby. That's why it's very expensive to maintain this facility, because it really needs to be 24/7 online. So every minute that you don't turn it on, Vienna will call you. Why is your station turned off? And with this, we ensure the public that the wind that is coming to the Philippines is not free of radiation. So it's turned on 24/7 as a baseline data. And then if there is a spike, then we know that, there's something out there. It is a network of these stations all over the world, and all these stations will report to Vienna. So there is a triangulation, no? If we read something, then I guess one other station should read something, and then another station should read something. So that's why all the stations should be turned on 24/7. So Ambassador Luli Arroyo, so the daughter of then President Gloria Arroyo, visited the CTBTO station in Tanay, because it is under her embassy, the permanent mission in Vienna, which talks to the CTBTO. That's why she visited us in the mountains of Tanay. And aside from, so you might wonder, that's only one station, right? Only in Tanay. What about Visayas and Mindanao? Are they not monitored? Because the air from Visayas and Mindanao is different from the air in the northern part of the Philippines. We have local radiation monitoring networks all over the Philippines to let you sleep well at night, and we monitor the gamma dose rate all over the country. So right now, this is just one of our very new stations. We call it Early Warning Radiation Monitoring Network, gifted by Europe, and it's scattered all over the country. Next slide, please. So it's scattered mainly on the west side of the country. So these are the monitoring stations, the new monitoring stations that we have, but we also have 14 other. So right now, a total of 24 monitoring stations all over the country to collect nuclear radiation data 24/7. Next slide, please. And also just an information, we tend to put our radiation stations also in Pag-asa stations, no? So one-on-one with Pag-asa, so that we are not there we don't need to have a personnel there, but the Pag-asa personnel is stationed there, so they take care of the stations that we have. And so we have an MOA with Pag-asa for renting out their stations. Next slide, please. And then finally, nuclear energy for power generation. And this is coming soon in the Philippines, hopefully by 2032. That is the goal, to put nuclear in the grid by 2032. It has been a long way coming. So you thought that this was only in the time of the now President Bongbong Marcos, but as early as 2016 and 2014, it has been a long way for us until we have signed a national position in 2022, putting the nuclear energy into the energy mix, because that is the first step. A country needs to have a commitment first that it will put nuclear into the grid. So it's not, there needs to be a national position, and it needs needs to be signed by the president. So it was signed in 2022 by then President Rodrigo Duterte before he left office. So it was signed February, but we have drafted the position. So it was during COVID that we drafted the national position, but it essentially took 1 year before he signed the national position. So these were all the considerations that you need to put in the national position: economic, political, social, environmental. So all this needs to be studied and sent to the president of the country. This is the so building a nuclear power, nuclear energy program is not so simple. It's not like a coal power plant wherein if some, like the Aboitiz, will want a coal power plant, they can build it tomorrow. So it's not as easy as that. Since the nuclear energy is a concern of the global community because of the impacts of nuclear, then the IAEA is watching all the countries or guiding the countries when they put out a nuclear energy program, and there are different milestones that a country needs to accomplish before it can pursue a nuclear power program. Right now, the country is approximately in this stage, or maybe moving already to phase 2, hopefully. And we are looking at 2032 to have a first light of our nuclear power plant. Next slide, please. So how do we do it? It's a lot of work. It's a lot of meetings. It's a lot of technical work from all the, what we say, NEP IACA, Nuclear Energy Program Interagency Committee. It's being headed by the DOE and vice chaired by the Department of Science and Technology. These are just a few of the very first members of the NEP IACA, but it has become very, very large already. I think there are more than 15 agencies that are in this NEP IACA. And this is the, aside from the milestones, there are 19 infrastructure issues that the Philippines needs to answer to the IAEA before they will approve each milestone. So these are all the milestones. So look at that. It's not as easy as building a coal power plant. Indeed, you need to satisfy all these infrastructure issues. So these infrastructure issues are the ones that are being checked by the IAEA before they can say, okay, you are done with milestone 1, check. You can move already to milestone 2, and it's really a global endeavor. It's not only a Philippine endeavor. So that's why to ensure that the nuclear energy, the nuclear power plant will be built in the country is safe, and will not have global impact, a bad global impact. So that's why it's always that we have the International Atomic Energy Agency with us. There's still a lot of ways forward for us until the 2032 deadline, but one of the most important task for the PNRI is to develop the nuclear regulatory framework. Right now, the regulatory mandate is with PNRI also. So it's the promoter and the regulator both in the same agency. So it's not a good practice, and no nuclear power plant manufacturer will want that. They really want a separate and independent nuclear regulator. And I hope in the next year that our nuclear regulatory division will be separated from the PNRI already, and it will be a new office like PhilSA. So they're really looking of how PhilSA was built from the ground up, because it will be their time soon. And I think they're also looking at the office here, at your offices here. They're already looking for offices where to rent also. Next slide, please. So just a few remarks on why nuclear power. I know that there's a lot of criticism on why we need nuclear power. Right now, this is the global status. You have actually 410 nuclear power plants in the whole world right now. You still have 57 under construction, and one will be turned on very soon. Bangladesh will actually turn on its very first nuclear power plant very soon. And then 10% share in world electricity right now. This was a question. This is a question whenever I go to public forums on why only 10%. It's 10% because the process is very, very long, actually. So it's 10 to 15 years to build a nuclear power plant. It's not like a coal or even geothermal is much easier than a nuclear power plant. That's why it cannot really have a big market. And of course, there's a lot of stakeholder consultations to have that. And so all over the world, as you see, nuclear is this green structure. It's pretty what you call that, constant through all these years. And we did see a very big dip around here because of, I think this was during COVID, and of course the effects of Fukushima, the Fukushima crisis. That's why there was a moratorium, I would say, of companies trying to build nuclear power plants. But after the COVID crisis, we've seen energy security all over the countries, plus the Ukraine war, all these happenings that are all over the world. They've seen that nuclear is the way to go, right? It's very stable. The market of uranium is very stable. You can get uranium in several different continents in the world. If there's a problem you have one in Kazakhstan. If there's a problem there, you can get it in Canada, you can get it in Australia. So the market is for uranium fuel is very, very stable. And of course, we call this era now the nuclear renaissance. No, a lot of countries are pursuing nuclear again after such a long time because of the problem of energy security after COVID, after the Ukraine war, and then we have several other wars coming at the moment also. So you have this regional distribution of nuclear power. The Asia is actually very, very fast because of China. China is fastly developing its nuclear power industry. I think it has 1,000 nuclear power plants of course, to fuel its manufacturing industry, right? So you need an energy source that is very stable and very constant and will be 24/7 turned on. So that's why China is very heavy on developing more nuclear power plants. That's why it's here. It's China that is leading Asia and the Far East in nuclear power plants. And as you see, a lot of other countries are still building or constructing nuclear power plants at the moment. So this is just the global status of the operating nuclear power plants. Right now, we still have a lot of nuclear power plants. Even in South Korea, you have 25. And you see all these countries are major manufacturing countries. No? So if you want to really industrialize your country, you need a cheaper electricity source and a stable electricity source that will not be affected with fuel prices, right? So that's why a lot of these countries right now are still considering nuclear power plants, and even the Arab countries. You know that that we have several Arab countries already building their own nuclear power plants, even if they have oil. They know that oil will run out, and if oil will run out and they don't have an alternative source, then it will be bye-bye for all the richness that they have. Next slide, please. So just why nuclear power? Of course, it's very high energy density. The strongest force in nature is still inside the nucleus. That's why you have a very strong energy density. If you use nuclear energy, one uranium pellet is actually equivalent to 120 gallons of oil. The energy that is produced by one uranium pellet is equivalent to 120 gallons of oil. And that is why you can see the very big magnitude of the energy density of even just one uranium pellet compared to oil or even to coal. So to coal, you need to burn 1 ton of coal, and you only need one uranium pellet, right? It's also considered a clean energy, clean meaning not zero emission. So I think the only zero emission, the zero emitting type of power is wind, but there is carbon emission, but it's very, very low compared to like coal and carbon. So many orders of magnitude smaller than coal or oil power plants. Next slide, please. And then nuclear power is actually a very mature technology. So you've seen nuclear technology since, of course, since the 1940s. After the war, they have developed nuclear technology for naval propulsion, and then after that for power generation. That's why in the market you can choose what nuclear technology you want freely. And with the Fukushima accident, so the nuclear power industry is very agile also in addressing the accidents that we have. And right now in the market, next slide please, we have the small modular reactor. So these are modularized, so like Lego reactor technology. They're quite small. They're only 300 megawatt or less than. So when you say small, it's 300 megawatt or less. The big build, we call big build nuclear power plants, are essentially from 300 up. So you have 1,200 big build nuclear power plants. And because they are small, these small modular reactors, the footprint is also smaller. And then if you decide that, okay, you're still not decided, you only buy one. And then if you are already convinced that this can give you good energy source, then you buy the next module. So you can just stick them together and then until you build the energy requirement that you have. And this is what you call a walk-away safe reactor technology. Because of what happened to Fukushima, so the Fukushima accident actually happened because the cooling water cannot be brought to the reactor pool. Why the cooling water cannot be brought to the reactor pool? Because the diesel generators were flooded. Okay, so it was on the basement. Actually, it was just this error that all the diesel generators were on the basement. No, so it was actually a lesson even for other industries, that never put your diesel generators on the basement of a building, because if it floods or it can, it was tsunami, right? So your diesel generator will not work. And because of that, they thought that a reactor should be able to cool down itself by its own. So this technology will, if there's an accident, the operator can just walk away and don't care anymore. And the reactor will be able to cool down itself just by, I think it's by normal convection, that the reactor will be able to cool down itself. So this is the lesson that due to the Fukushima accident that we have. That's why we have the small modular reactors in the market already. And from small, you can still go smaller. You can still go micro reactors. Micro reactors are essentially 10 megawatts or less. So this is very perfect. That's why a lot of politicians come to us to check what is this small modular reactor technology, because they are island provinces. They don't really require a lot of power, but they don't have power on their own. Their power is very expensive. So if an island province wants its own reactor, then there's what you call a micro reactor already. It's 10 megawatt. It can be carried by a truck. And then you push your your power lines to your power to the grid. So this is factory fabricated, so it will be brought to the Philippines in a big ship, and it will be ready to be deployed. And usually the fuel type is very new type of fuel, but yeah, this is still, the concept is still there is still no built microreactor at the moment. GE has all their plans for it, but yes, we still need to see all this new type of technology. Even the small modular, there's Canada is first in building it, but they're still not operating. So hopefully in like 2 or 3 years, we see all this new reactor technology come into fruition already. So this is a very good picture of what was sold in the 1950s without nuclear power plants and what is sold in 2000s right now, right? So we could have been that if we were able to push the nuclear power plant use in the country, but it is what it is, right? It is our history already. Therefore, we just need to do better this time when we have already the two presidents, the past president plus now, who is very supportive of having nuclear power in the country. So that's why we are working very hard that all the big plans are in place so that by 2032 we have a nuclear power plant already in the producing power in the grid. All right, so these are just my thoughts and my last slide of areas of collaboration between PNRI and PhilSA. I have just this anecdote to tell, because if you know the INSO, the International Nuclear Science Olympiad, which happened this year, one of our contestants won a gold. It was a Muslim student. He won gold in the INSO, and of course we trained him very well. And then he entered into the astronomical Olympiad also, and he also won gold there, while the other contestants won only bronze, but he won gold. And his story was because what we taught him in nuclear science was he was able to use in the astronomical Olympiad as well. So I said, really, nuclear and astrophysics, astronomy are like brothers and sisters. If you teach this in nuclear science, it can be applied also in astro. That's why he was the only contestant among the four who won gold, because he said what we taught him in nuclear, he was able to apply in astro also. So that's why we have a lot of areas of collaboration in terms of detector technology. We can develop because we also have some collaborations on different detectors that we use. I know we are detecting alpha, beta, gammas, but I guess the energies are in the same range, and X-rays also. We are dealing with X-rays, and then we can have a lot of R&D on radiation hardness testing for your electronics and hardware for the satellites that you will be bringing to space. So as I was telling Sir Marcos, Analog Technologies is already giving it to PNRI finally. So they're sending their electronic components to us for irradiation. We can also work on the same projects wherein we will try to do R&D on different aspects of space radiation. And then, of course, an environmental mapping. I have a slide on the various, we are using C14 isotope analysis and how it affects a certain area in the country. So perhaps we can also have a collaboration and environmental mapping. And as mentioned, we have a health physics section, we have a biomed section. All of these is just similar to what you want to see in space, right? How will I just put biological materials. How will biological materials react to radiation in space or in different conditions in space? We have that. So we have biomed, we have health physics group, which we can all collaborate on certain R&D on space for irradiation experiments for biological materials. And then, of course, many more that we can talk together and see what will be the future R&D directions that we can do together. together. All right, and with that, maraming salamat po. If you have further questions and clarifications, or if you want to collaborate with us, please feel free to email me, and we will be more than happy to collaborate with you. Thank you very much.
Okay, so thank you very much, Dr. Samson, for delivering that informative presentation about the overview and the current initiatives of PNRI in regards to nuclear technology and also possible areas of collaboration between PhilSA and PNRI. I hope everyone here and those who joined online has learned something new today. Now we are opening the floor for questions. Please introduce yourselves and division, and to our online viewers, you can also drop your questions in the comment section and we'll come back to check on you later. So are there any questions from our audience?
Hello. Thank you very much for the great presentation.
Thank you.
I'm Ellison Castro from the Earth Science and Space Studies Mission Studies Division. May tanong lang po ako regarding po dun sa nuclear detector from sa Tanay Rizal tapos yung mga maliliit na sensors throughout the countries. Ano pong specific measurement po yung ginagawa niya?
Okay. So these for the Tanay one, they need to measure the radionuclides. So there is a very big dish, and on the dish is actually a filter, a 1 meter diameter filter, and then they collect the air. Then after the collection, they cut that 1 meter diameter filter, and then they put that air filter, we call air filter, on top of a gamma spectroscopy setup. So the gamma spectroscopy will give you the different radionuclides if there is on the air filter. So that's for the CTBTO. So it's quite high-tech because it's gamma spectroscopy itself, and so you will really see a spectrum, and then you will really see all the radionuclides that are present. For example, they say that when it's New Year, there are certain radionuclides that can be seen only when it's New Year because we have a lot of fireworks. But of course, these are short-lived. These are short-lived radioisotopes. But yeah, so these are some of the radionuclides that can be seen. And of course, if there is a nuclear accident, then the type of radionuclides to be seen should be very, very different already. So that's for the CTBTO. And but for the local monitoring stations, it's actually just your regular radiation monitoring sensors, which is most of the time sodium iodide scintillator detectors. And so they accept everything, whether it be alpha, beta, gamma, and then they just sum up the radiation that they have, and then the data is in radiation dose, so something like microsievert per hour. So and then it will just be the data per minute or per hour will just be microsievert per hour. So it's a total gamma radiation dose of that particular location. So mas not as high-tech yung mga local radiation monitoring networks natin, but because a gamma spectroscopy measurement machine is also very difficult to maintain, you need a liquid nitrogen 24/7 to it. So that's why with the gamma radiation detectors, it's just you can just put it there, and then it will already give you the radiation dose in a per hour or whatever type of time scale that you have. So yun yung ginagamit sa Philippines, but it already gives you a very good baseline, no? That for example, in certain parts of the country, it's 5 microsievert, no? And then you see that kung tumaas sa 5 microsievert, then something is wrong. But it gives us an overall baseline. That's why we're regularly monitoring, just so we know, no, that this is the baseline, and if it becomes higher than this, then something is happening.
Available po ba yung data nung sa Tanay?
Ha?
Available po ba yung data nung sa Tanay?
Oh, the data is actually owned by the CTBTO, but yeah, a lot of my colleagues, even in NIP, are interested with that. That if that data can be made available, right? Even past data, but we have to check. I have to check if that data can be gotten by other agencies, even the past data. So some research institutes, kasi they make available past data, right? Not the current, but the past. But I can check. Yes.
Okay po. Thank you, ma'am. Thank you, ma'am.
So we have another question.
Hi, good morning.
Hi,
Thank you
Raymar.
for visiting us.
Former PNRI employee.
I'm Raymar from SDMAD. May I know what is the state of uranium exploration in the country? Where are we going to source the uranium for the nuclear power plant?
All right.
And last question po, do you have an official statement about the supposed uranium mining by the Chinese in Camarines Norte? Thank you.
All right. So all right. So on the news. So first on that news on the uranium mining, we are not giving because we don't know any data of it. We can't say anything on it yet because it was just 2 weeks ago. Plus, there's a lot of flooding in Camarines Norte. So we don't. There is no information coming from us from the DNR. So the DNR should be giving us that input and telling us that if we can assist them, but there is no official confirmation from government agencies that can be involved with that, and therefore we can't say anything on that news on the uranium mining in somewhere in Camarines Norte. And then the second is, what is the state of uranium exploration in the country? We do have several. We are still trying to find uranium mines in the country. We have several sites. I'm not just familiar with all the sites that are being studied right now for uranium, but as far as I know, the uranium that we have here in the country is quite low grade. It's low grade, therefore the purity is not good yet, the ones that we have, and therefore it would be cheaper if we would just buy the uranium fuel from a source rather than trying to mine, do R&D, and then trying to refine it and process it. So that's why that's the status now. The uranium that we have are like low grade, essentially because I don't know with the geology of it, but most of the best uranium in the world are found in the continental countries. So you have Australia, the Russia, so that's Kazakhstan has, plus Canada. No, these are continental countries, and maybe it has something to do with our Pangea of old. That's why they have better uranium. But the Philippines is a very young country in terms of geological timescales. That's why our uranium is not as good as the ones coming from continental countries. Thank you, Raymar.
Okay, so we have another question.
Hi po.
Hello.
Thank you sa presentation po. And same division po. I'm Vion Aquino.
Yeah.
And follow-up question lang po. Few years back po, naka-attend ako ng seminar from PNRI regarding San Vicente, Palawan, yung radioactivity. So, ayun po. And siguro include na rin po yung rare earth.
Yeah.
Yes. Yung update lang for status po. Thank you.
We have not been actively doing some exploration in San Vicente right after the pandemic. Medyo hindi kami nakakarating na, as far as I know, hindi na kami nakakarating ng San Vicente. And indeed, that area there has some rare earth elements that can be used not only for but what you call that, critical minerals ba yung tawag sa REEs, no? So but we still have not gone there yet, and indeed it's we need to revisit that on how we can inform the local stakeholders that they have such a type of mineral in that area. But that's a very beautiful beach. I know it's a very beautiful beach, and sayang naman kung kung miminahin, but hopefully there will be a more eco-friendly way of mining such minerals. But yeah, it's one thing that we need to revisit again. Medyo hindi na namin napupunta ng San Vicente.
Okay, so we have a question here online. Is 2032 also the same timeline for private companies regarding nuclear reactors, specifically either modular or not?
Yes, in the Philippines, power production cannot be government. No, so it's in the IPIRA law that the government can make policies. So right now, what the government is doing is crafting out all the policies, but ultimately it is the private industry that will have to build their own nuclear power plants. And luckily, there are a few power generators, industry power generators that are interested to also go nuclear. I know of one company that wants to use a microreactor for their data centers. You know that data centers are very, very power hungry, and they want their own reactor because they cannot rely on the grid, right? What if there's a big typhoon and then you need to shut down your data center? So they want to use those technologies for certain very special applications already. But it will be industry or private industry driven. So the government can only lay out all the policies, but the industry or the private companies needs to be the one to buy those reactors. So that's why we are already engaging with them as early as now. We've had several meetings and visits to other countries so that they can see what are the myriad of reactor technology they can buy. No, so they will just have to choose what reactor technology they will buy, and then they will have to license it from the government, and then they will have to operate and do the power generation. So that's not unlike the 80s where I think PNOC was a government. So in the past we were producing power, government was producing power, but now it's only the private that will have to buy whatever reactor technology. And yes, it should be 2032. That's why we're already engaging heavily even with private enterprises already.
Okay, so are there any questions from our on-site participants? I have a personal question.
Yes.
So regarding 2032 target, does it involve already the recommissioning or the commissioning of the BNPP?
Okay, so BNPP is really always on the radar of Filipinos because it is already there. I know that it's already there, but it's an old structure. So it was done in the 1970s essentially, and after that there was no upgrade or there is upkeep. There's winawalis lang nila yung ano do. But the general upkeep, you know buildings, di ba? Yung mga buildings natin every 10 years ina-upgrade natin. But that building I've never seen that. That's why before we can say that BNPP is a good alternative, we need to study first, right? We need to do an R&D and do NDT of the whole building, whether it can still withstand and it is still up to standard. All that was done in the 1970s. And if have you been to the BNPP already? Okay. So it's a very big museum. It's a good tour to have. And there's also a good beach beside. So pwede kayo mag-team building doon after nyo mag-tour doon sa facility. You can just ask, I think who's the owner right now? The owner is I forgot who's the agency that is the owner for it. But you can if you you look at the external structures, the reactor pool is still very, very solid. Even the paint is still like 1980s paint, because they said that that is what a reactor should be. Like the type of paint is really very different from like normal construction paint and for houses and buildings. That's why the reactor is still very solid, but all the external components like the turbine and all the wires under and the plumbing is I think would be in a very bad shape already. So it still needs to be studied whether it's better, what will be cheaper, to just start from scratch or to revive the BNPP. So it still has a lot of economics also, plus a lot of R&D. So we cannot say for sure yet if the BNPP is the best way to go, because there's no data yet to support that. So we still need to study. But the structure is still there. That's good. The dome is there, and if I think that dome can withstand G, a gravitational constant of 0.4 G. So if there's an earthquake, it's best to be in that building because it can withstand 0.4 G of seismic what you call this, oscillation. So that building is really built well, but yeah, with today's standard, because that was the 1980s standard, so 1970s pala. So we have to check if it is still at par with today's standard and if the structure is still intact. That's why I can't say for sure yet.
Okay, thank you. Do you have any final questions for our resource person? Okay, so with that, thank you, Dr. Samson, for your time and valuable insights in regards to nuclear technology and possible applications for space science. To give the tokens of appreciation and awarding of the certificate, may I call upon Dr. Gay Jane P. Perez, Deputy Director General for Space Science and Technology, and Dr. Ariel C. Blanco, Director for Space Information Infrastructure Bureau and OIC of the Space Science Missions Bureau, and also Dr. Mark Cesar R. Talampas, Director for Space Technology Missions and Systems Bureau. So let me read the citation. Republic of the Philippines, Office of the President, Philippine Space Agency, Certificate of Appreciation is hereby awarded to Dr. Vallerie Ann I. Samson for sharing her expertise and knowledge as resource speaker during the HugNayan Space Science Fora held on October 28, 2024. Given this 28th day of October 2024 at Philippine Space Agency, 11 Eastwood Avenue, Bagong Bayan, Quezon City. Signed, Dr. Gay Jane P. Perez, Deputy Director General for Space Science and Technology, and Dr. Joel Joseph S. Marciano Jr., Director General.
Gay is 1 year younger than me in NIP.
Before we formally close the program, may we call on the Deputy Director General for Space Science and Technology, Dr. Gay Jane P. Perez, for the closing remarks. Let's give her a warm round of applause.
Thank you, Sunny. Actually, I have a question. No, I was waiting for you to look at me earlier. But so if you don't mind, it's not a personal question, but maybe an aspirational one, something about the future. And I'd like to get the thoughts of our, of course, distinguished resource speaker on that. We all know about the future of space mining or extracting minerals from space, from celestial objects. And earlier you mentioned, I think there was a question about uranium,
Uranium,
or something,
uranium mining.
critical minerals that are used for energy production.
Electronics also.
Yes. Now my question is, what do you think is necessary, both in terms of the research capabilities and also policies, in order for the Philippines to be ready when time comes, when we need, or when there is the possibility now of having our space industry extract or harness these resources from space, from a PNRI perspective.
From a PNRI perspective. So from a PNRI perspective, we need to start on a small scale first. We need to start on a small scale. Plus, we need to develop the people that will have to analyze. Let's say we will already be taking all those minerals from space, then we need to train the people how we will be able to analyze those. And of course, these trainings, for example, I know that X-ray fluorescence is actually used in Mars rover for exploring the geology of Mars, and we have X-ray fluorescence here on Earth, right? You can use it here. So some technologies can actually be learned while here on land and not yet being used in space. So as long as you know how to read them, because apparently not all know how to read such data, and therefore we need to develop such expertise also on instrumentation and detection. Because if you are already sending, for example, your equipment there, and then you thought that it was rhodium, because we've seen this already, that there was an X-ray technician telling the customer that the rock has rhodium, when in fact it was just the X-ray tube scattering. So these things should be learned well while here on Earth, because you can't have many such errors already when you are already mining it from space. And these expertise can already be learned here while it's not yet, while it's not yet possible to do that. But all the science, all the technology and instrumentation can already be learned here, so that once we are already doing it, then our people are already very well capable of. Because I really remember that some company used, I think it was an exploration company also, they have a certain rock and then they ask someone to analyze it. And then the analysis came out that it was made of rhodium, but it was the rhodium X-ray tube that was giving that data. So these things will cost you so many. If the scientists, the researchers don't know this very basic fact, then you thought that you are collecting rhodium from outer space, only to find out that it's only calcium. So the rock was only made of calcium carbonate, actually. So you see, so this and you cannot be doing this in space. So that's why the science should be solid here, right? So the science and the capability should already be solid here while we are not yet doing those things. And of course, a lot of instrumentation, I would say, developing the instrumentation. You need to be able to develop remote instrumentation and learn how to do a lot of remote instrumentation. Even for us, for PNRI, we are still struggling with that, because nuclear is like space, right? You cannot be inside a very high radiation dose reactor. So you need to develop also like robotics, instrumentation to be able to do mapping or to get what is wrong in a very high radiation dose pool. So those are the things, Dr. Gay, to develop all our expertise now here on land, because these expertise is already here, but we just need to develop that. And of course, all the on remote instrumentation, detector technology, plus all the science we can already try to develop here. In terms of policy, in terms of space mineral policy, I don't really have an answer to that yet because I don't know what will be the implications, and I don't think anyone has thought of it right now. But it's good that PhilSA is already thinking about that, on how to develop policies, because policies take years and years to develop. Like, for example, for our NEP IAC, it's already running 10 years of policy work. But yeah, so policy work is like 10 years in the making. So you develop it now, then perhaps after 10 years, 20 years, it's already there, then it's already implementable by that time. That's my advice to Dr. Gay.
All right. Thank you so much. Indeed, this is a very insightful morning for us. We learned a lot about PNRI, its roots, PAEC, and what they're currently doing now, and more importantly, what we can do with them. It's very good that Dr. Val identified some of the topics or areas where we could collaborate with. I must say that PNRI and PhilSA feels like, well, Dr. Val said they're like siblings. I also feel like there's an umbilical cord connecting these two agencies or research institutions, especially from my perspective as a physicist. So I'm speaking as a physicist, not as a deputy DG. I believe, or I would share that if you are a physicist in this country and you don't want to work in the academe, meaning you're not teaching, and you're looking for a research institution, it's either PNRI or PhilSA. I mean, sorry, don't quote me. It's just a personal view. And you will see that, I guess, with people working there and here, there are many common things that tie us together. Dr. Val already mentioned she's 1 year senior than me. My closest batchmate is working in PRI since she left UP. I'd probably have worked there as well if I did not choose this path. So, but we share a lot in common in terms of, I guess, the foundational physics that supports what we are doing. And it's good to see how this is realized into technology, and for us into space technology. It's also quite interesting. When I left NIP, I thought I'll be far from PNRI, but when I joined IESM, environmental science, there's the connection again, because as you see, there are a lot of environmental applications from nuclear science. So I guess we are really meant to be working together. And as Dr. Val already mentioned, this has been much awaited meeting of minds. Finally, it took us a while to get her here. And therefore, my call to action to everyone is I hope we don't end here. Let this be a start of things that we will do more actively, more closely with PNRI and other organizations as well in the country, universities who are working on this field of science. So please keep that in mind. Dr. Val will be here for a few more minutes after this. Hence, I invite those who are interested, who have burning questions but are too shy to raise it to her earlier, to join us for a short discussion. And again, this is just the start. We hope to continue this conversation and and engage with PNRI more closely in the future. All right, thank you. And with that, good morning, everyone.
Thank you very much, DG Gay, for your message. Now we have finally reached the end of our program. It's been a great day and a wonderful morning with all of you. Thank you to all of you. Thanks to all of your participation. And I'm inviting all attendees to join us here in front for the photo opportunity together with our resource person. And before that, don't forget to evaluate this as HugNayan Space Science Forum via this QR code. We are also sending the link in the chat later on. Okay, so pwede na po tayo dito sa unahan for the picture taking po. Again, for all our participants, don't forget to evaluate today's HugNayan Forum. To all our online viewers, we'll now be signing off. Once again, thank you to all your participation